Hello everyone, my name is Raphael, and in this short video I'll be reviewing query optimization. The overall path is listed in 3 steps: parsing, optimization, and evaluation. Within parsing, the query is translated into its internal form, thus translating into relational algebra. Parser checks syntax and verifies relations. Within evaluation, the query execution engine takes a query evaluation plan, executes that plan, and returns the answers to the query. As far as understanding optimization, I would like for you to imagine yourself standing in front of an exquisite buffet. Your goal is to try them all out, but you need to decide in what order. What exchange of taste will maximize the overall pleasure of your palate? Query optimization is the answer. Once again, the query optimizer, called simply the optimizer, is a built-in database software that determines the most efficient method for an SQL statement to access requested data. The optimizer attempts to generate the most optimal execution plan for an SQL statement. Thus, query optimization is the overall process of choosing the most efficient means of executing a SQL statement. For example, Optimizer chooses the route with the lowest traffic conditions among all considered candidate plans. The optimizer uses available statistics to calculate traffic. For this reason, all SQL statements use the optimizer. The database optimizes each SQL statement based on statistics collected about the access data. The optimizer determines the optimal plan for an SQL statement by examining multiple access methods, such as full table scan or index scans, different join methods such as nested loops and hash joins, different join orders, and possible transformations. For a given query and environment, the optimizer assigns a relative numerical cost to each step of a possible plan, and then factors these values together to generate an overall cost estimate for the plan. After calculating the cost of the alternative plan, the optimizer chooses the plan with the lowest cost estimate. For this reason, the optimizer is sometimes called the cost-based optimizer, to contrast it with the legacy rule-based optimizer. An execution plan describes a recommended method of execution for an SQL statement. The plan shows the combination of the steps executing an SQL statement. Each step either retrieves rows of data physically from the database or prepares them for the user issuing the statement. An execution plan displays the cost of the entire plan, indicated on line 0, and each separate operation. The cost is an internal unit that the execution plan only displays to allow for plan comparisons. Thus, you cannot tune or change the cost value. Cost is generally measured as total elapsed time for answering query. Many factors contribute to time cost: disk access, CPU, or even network communication. Typically, disk access is the predominant cost and is also relatively easy to estimate, measured by taking into account number of seeks, number of blocks read, and number of blocks written. It is also noted that the cost to write a block is greater than the cost to read a block. Finally, data is read back after being written to ensure that it was successful. In conclusion, starting with parser and translator, when it is parser translated, into a relational algebraic expression as shown at the very beginning of this video. It is then optimized so it can be made efficient. And to optimize this, we use information regarding statistics. For example, how many tupules actually exist in the relation right now, and so on. Based on statistics, we will decide on an execution plan. An execution plan is how we actually want to proceed and what actions to take in terms of accessing the different indexes to evaluate the query. Finally, out of that, the query output will be generated. In conclusion, query optimization chooses the one that gives the minimum cost, and the cost is estimated based on statistical information from the database catalog. For example, number of tupules in the relation, the size of the tupules, the attributes on which frequently conditions are tested, and so on.